Okay, so looking at 67 and 68, it says the graphs below are complete graphs. That is, it is continuous and displays the functions in behavior. All zeros are integers, so they mean like whole numbers. And answer the following questions. So list the zeros whose multiplicity is even, and then we're going to list the multiplicity if it's odd. And then we want to go ahead and give the equation for that. And I give you a little hint that you want to go ahead and write your solutions as factors and then write that as a product of factors for your equation. So first, let's review what multiplicity means. So multiplicity refers to whenever you have an equation like y equals, and if you've factored it, you might have something like x plus 2, and then you might have something like x minus 3, and that x minus 3 might be raised to a power of 2. And so the multiplicity is referring to whatever the powers of the factors are. So in this example right here, my even multiplicity would be right here, and that solution would be 3 though, because the solution is asking you what would make the factor equal 0. That's why we call them zeros, okay? So the even multiplicity would be for the solution of 3, and the odd multiplicity solution would be a negative 2 for this example that I created right here. Now, whenever you graph them, they look different depending on if it's even or odd multiplicity. If it's even multiplicity, what happens is, and if you look at our graph down here, um, even multiplicity, it it kind of looks like a parabola, especially if it's a square. If it's a square, it kind of has that parabola shape, so it doesn't cross the axis. And if it's odd multiplicity, it's more like a line. Um, if you go up to like a power of 3, it can kind of look kind of interesting, but it crosses the x-axis. But we're only going to focus on multiplicity of 1 and 2. But it can definitely go higher, but that's all we kind of focus on in our course. So let's go ahead and answer these questions now. So a lot of times students, they get thrown off by this right here. You can just really ignore this. This is just telling you how the graph is broken up. That they're telling you this is the x coordinates and this is the y coordinates. They're just saying that the x axis goes back 3 spots and forward 6, and they're counting by ones. That's what that means. And then the y-axis goes down 10, up 10, and they count by ones also. So really, for the most part, you can kind of ignore that. So even multiplicity, we'll start with that first. And so we have that at right there at 3. At 3, we have even multiplicity. And then for odd multiplicity, we have it right there at negative 1. Negative 1. And then the last part, what we're supposed to do is go ahead and write the equation for this. And so this would be y equals, and it doesn't matter which one goes first. So the solution 3 written as a factor would be x minus 3, because 3 would make this factor equal 0. And then its multiplicity is even, but more than that, it's 2. And then here, when we cross at negative 1, that factor would be x plus 1, and it has a multiplicity of 1, which you really don't need to put the 1 there. It's already understood. And so that would be our equation. So those are the 3 parts that you'll be asked. 68 is actually pretty similar question. And so once again, we'll start with where's the even multiplicity, and that would be right here at the bowl shape, which would be a 1. The odd multiplicity would be back here at negative 2. And then the equation for this would be y equals x minus 1, and that multiplicity is a 2. And then x plus 2, that multiplicity is a 1, and we'll just leave it just like that. All right, hope that kind of clears that up for you.